I received a question from a student. I couldn't understand this paragraph. Can you explain this, please? If you don't know where this text is from, it's from the resource book published by NIE. You can go to the NIE website and download it if you already haven't done it. This part is in Unit 1 where they discuss de Broglie's hypothesis. So what exactly did de Broglie propose? De Broglie proposed that the wavelength of any object, anything, whether it's an electron or a coconut, it depends on the mass of that object and the velocity. So de Broglie's hypothesis is that the wavelength of anything depends on mass and velocity of that thing. And you know, this relationship is given like this, where your h is the Planck's constant and this is the momentum. We can expand the term P as mv. So what I'm going to do here is just remove that and add mass and velocity over here. And what this paragraph says over here is that this relationship can be applied to anything, any matter, be it an electron, a single atom, let's say a hydrogen atom. If you want, you can apply this de Broglie relationship, this concept, into an atom. If not, you can apply it to a molecule, this whole molecule. And if you want, you can apply this to a human or even a coconut tree. So the lambda is dependent on the mass and velocity. If you compare an electron with respect to a human, think about the masses. Electron is very light. So because lambda, this wavelength, is dependent on the mass and also the velocity, the wavelength given by a particular object is going to be characteristic or unique. So the wavelength given by electron is not going to be the same wavelength given by a human. When you examine this relationship, do you see that the wavelength and the mass has inverse relationship? What does that mean? That means if your mass is going to increase, your wavelength is going to decrease. Now compare the electron with respect to the human. The electron is very light. So considering this inverse relationship, if your weight is very small, if m is very small, your wavelength is going to be very high. So this electron is going to have a large lambda. On the other hand, human is very heavy compared to an electron. So in the case of the human, your mass is high. The denominator is large. You know what happens when you have a large denominator? You're going to end up with a smaller answer. So the larger m means you're going to have a very small lambda. So this is large M. This result in small wavelength. This is what it means. So if you consider an ordinary object that you can actually see with your naked eye, for example a golf ball, compared to something like an electron, golf ball is still very heavy. So because its M is large, its lambda is going to be so small that you cannot even observe it. As for the electron, since the electron is very small, the lambda or the wavelength given by the electron is going to be observable. Because the mass is small, the lambda is going to be large. Let's crunch some numbers so you will have a better idea. Find the wavelength, the lambda, for an electron that is traveling at a velocity of this. So this is for the electron, and also we'll find the lambda of superman flying at the same velocity, because we cannot compare a regular man traveling at the same speed. You know the mass of an electron. Remember, we are taking that in the units of kilograms, and let's say our superman is like 70 kilograms. Use this equation pause this video and do the math yourself and see what the values you get for lambda. Now you can compare what kind of wavelengths we get for the two different objects of very different masses. For the superman, can you see how small this wavelength is? If you go and check the wavelength, the numbers in the electromagnetic radiation spectrum, you will find that this wavelength of the electron fall around X-rays. This wavelength is somewhat closer to X-ray wavelength, whereas Superman's wavelength, it is even smaller than the gamma rays. It is not observable at any ways. Let's see how the knowledge given in that particular paragraph was tested during the exam. This is a question from the 2021 paper. It's in the structured essay part. This is a true or false type question. The de Broglie wavelength associated with the nitrogen molecule is shorter than the de Broglie wavelength of the oxygen molecule when traveling at the same velocity. From the two molecules, oxygen is the heavier one. When the mass increases, the lambda is going to decrease. For nitrogen, it's lighter than oxygen, so its lambda should increase. So technically, oxygen should have the shorter lambda. But the statement says the wavelength associated with nitrogen molecule is shorter, so this statement is false. So you can see a small paragraph that you might be struggling to understand can be tested in the exam in a very straightforward manner.